Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which finds sum of k smallest elements in a binary search tree. First, let us take an example. In the first example, if k is equal to 3, then the sum of elements will be 2 plus 7 plus 8. That is 17. The idea is to traverse BST in in-order traversal. Note that the in-order traversal of BST accesses elements in sorted order. While traversing, we keep track of count of visited nodes and keep adding nodes until the count becomes k. Now, let us see the algorithm. Let us also have a sample tree to test our algorithm. We assume that we have to find the sum of 3 smallest elements. So we pass the root node, which is 8, and 3 to k in the kth smallest element function. Next, we take a count variable and initialize it to 0. We pass the root k and count to k smallest element sum rec function. Now, in the k smallest element rec function, we check if root is null. As it is false, we check if count is greater than k. As it is false, we compute sum of elements in left subtree. So, we take a variable res and pass the left child of 8, which is 7, using a call stack. Again, as root is not null, we check if count is greater than k. As it is false, we pass the left child of 7, which is 2. So, root will point to 2. Since root is not null and count is not greater than k, we pass the left child of 2, which is null. So, root will now point to null. Since root is null, we return 0 to the previous call. Execution for node 2 is resumed, and now we add root to res, so res will be 2. Next, we increment count, so count will be 1. Since count is less than k, we return right subtree nodes. So we pass the right child of 2, which is also null. So root will point to null. Since root is null, we return 0. We return 2 plus 0, that is 2 to the previous call. Execution for node 7 is resumed, and we check if count is greater than or equal to k. As it is false, we add root's data to res. So res will be 9. Next, we increment count. So count will be 2. Since count is not greater than or equal to k, we pass the right child of 7, which is null. So root will point to null. As root is pointing to null, we return 0 to the previous call. We return 9 plus 0, that is 9, and finish execution for node 7. Execution for root 8 is resumed, and since count is not greater than k, we add 8 to res. So res will now be 17. Next, we increment count. Now, as count is equal to k, we return res, which is 17, and that is the final answer. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.